I mean, it's recording right now. All right, folks. Do you remember where I was? Was I on chemical equation?
Yes.
Good. Right here, right? I remember. Okay, so this is the thing. There are four. So how do we write a reaction is what it is. Always remember, on a reaction, you're going to have reactants on the left. Reactants meaning what? Things that react on the left. And you will have your products on the right. So the product means the things that result because of what you've done, right? So you will have products and reactants on the right, and they will have symbols. So they'll say whether they're the gaseous state, whether it's the liquid, solid, stuff like that, yes? Then the reactants are written to the left, and you will have a plus sign if you want to show two things reacting, right? Likewise, if you have two or more products, you will use a plus sign for all of them. You will have physical states, gas, liquid, solid, within parentheses. We will see all of that right now. So rather than show this like, maybe it's better to just see it like this, right? So here, do you see HGO is what? What is it? Is it a reactant or is it a product? Exactly. And then you have the solid, the S symbol, right? In parentheses, that means it's a solid state. Then you have an arrow showing you that what is going to happen to it. The little triangle on the arrow is telling you that you have to heat it. So remember, chemistry is full of symbols. We tell a story through symbols. Okay, so triangle means heat. You will decompose it, meaning break it down to two things. Mercury, which is a liquid, and oxygen gas will be evolved. By the way, this reaction used to be done in people's garages 20 years ago, 30 years ago. This is how people, mom and pop stores, sold mercury in bottles for regular consumption. People, you know, the very good old days, when my dad was a kid, my dad is 83, and he was a little child, they would use mercury to cure lice. So people would just put mercury on their Yes, they realize that they kill lice immediately almost, right? Because very toxic, but of course it would kill you too then. So that's why people stopped doing it. But in those days, mercury is so easy to make, because all you have to take is mercury oxide, and you can buy it and just heat it. All you need is a little pot and a gas stove. So it's easy to make because you only have two byproducts, mercury and oxygen. You know what's going to happen to oxygen gas, right? Not a bad thing to have. So that's that. Any questions? Okay, so there are types of reactions. So now that we know how to write a reaction, we're going to consider types. There are four classes or types. Before we do that, let's look at some indicators for whether a reaction has even taken place. So you have release of a gas, yes? You have a release of a gas, formation of a precipitate. You might have a solid form. If you have a solid form in your test tube, some of you did the lab yesterday, did you not? I think Brianna did. And those of you taking the 1105 lab, you will do it this week if you are in the lab section. But basically, you will see a precipitate, meaning a solid form. So if you take two clear solutions and you mix them and you see a solid, that's an indication that something has happened. That's a reaction. Bubbling of gases is a reaction. Color change is a reaction. The test tube becoming very warm upon touch is a reaction. Okay, all of those are, you may even see light. Some reactions do give off light, because light is after all a form of energy, right? It may give off light. So, now there are four types of reactions: combination, decomposition, single and double replacement, okay? Now the combination and decomposition, I expect you to be able to recognize. But the double replacement, we will actually do it together, okay? It's a reaction that you will, so basically I might give you the reactants and I might say predict the product. So that's the type of question that you have to spend some time on. The other types, you need to be able to recognize. So what is combination? Well, here's the trick. In a combination reaction, you will have fewer reactants, you will have more reactants, fewer products. So again, see, if you don't know what a reactant or a product is, you're not going to understand this. So what is a reactant again? On the left. So you're going to start with more reactants, but you're going to have fewer products. Does that make sense to you all, please? So, example, look at the two examples at the bottom. Don't worry about the numbers in front like this. We're going to get to these in just a minute. Okay, called coefficient. So look at both these reactions. Do you see more reactions? The fewer products, they're coming together. So think about it as combining, right? Combination means combining to form one thing. Yes?
Combination reaction, like the product that have a plus minus two.
Yeah, because there's only one product, right? So if there's only one product, no, you won't have the plus. So you don't have to memorize this. This is just merely a list giving you all the types of combinations that you might encounter. Don't memorize it. What I told you is you need to be able to recognize it. Okay? That's it. Is that understood, folks? Good. So we move on to the next type of reaction, that is what? Decomposition. Decomposition is the opposite of combination. So you're going to start with one reaction and you're going to break it down. So you're going to have fewer reactions and more products. Does that make sense? Now see there's a plus sign in between the products, right? A plus B. Because you have more products. Because that's the example of the mercury, making mercury in your backyard. That's an example of decomposition, right? Because you took mercury oxide, you broke it down to mercury and oxygen, right? So that's a decomposition reaction. Other examples are up here too. So again, I want you to be able to recognize them, okay? If you see a reaction, you should be able to say, oh, that's decomposition, or that's combination. And again, you don't have to worry about that. That's just giving you examples. Then there's single replacement. In single replacement, typically, you start with a metal. The A that you see there is often a metal. BC, the compound, BC, is an ionic compound. Now you know what ionic means? Ionic. Is this ionic? Is this ionic? Silver nitrate, is that ionic? Yes, it is. Ionic means what? What does it have to have? How do you recognize an ionic compound? It must have a metal and a non-metal. Right? So you're going to start with a metal, copper. Look at that example. Copper is going to replace what? Silver or nitrate? Silver. Copper replaces silver. So the product, you have copper nitrate and silver. Does everybody get that, please? Now I want us to write that equation by ourselves, please. Okay? Now this is something you should be able to do for me on the test. So I might give you the first part, like copper plus silver nitrate, and I might say, how about you predicting the product? So let us please do this together. Ready? I want you to write down copper plus silver nitrate on a separate piece of paper. Copper plus silver nitrate. No, it doesn't. See, the stylus doesn't work either. So much for all that. I tried the stylus. See, it's like silver. It's worse than my finger. Okay, copper plus silver nitrate. Okay? Now, I want you to, I'm sorry? This is Ag. I'm sorry, that's Ag. That's better? Okay. Now, I told you to single replace it. So, this is the problem I see on the test. Don't write anything, please. This is what I see on the test. Oh, that's easy. Students say, all I have to do is replace silver with copper, so my product will be CuNO3 plus Ag. That's what they say. Is that correct? What's wrong with that? Well, okay, that's fair. Okay, so actually, you might just have silver in the solid state. You might have metallic, because look at copper. Do you see Cu? I didn't have a charge on that, right? But what is wrong with this equation is that you haven't worried about charge. So it's not about just putting symbols together. It is about putting them correctly together. Do you see what I mean? Okay, so I want you to look at silver nitrate. What is the charge of nitrate? And that's what you need to write above it, -1. What is the charge on the silver if nitrate is -1? +1. Now, copper is a tricky one, I have to admit. Copper is a tricky one, but I'm going to tell you its charge. Assume copper to be in the +2 state. Assume copper to be in the +2 state. Now, can you tell me what is going to be the formula for copper nitrate?
So, you had no 3 plus 2, 2.
Okay, I'm just going to delete that and write it again. And, okay, now tell me what the formula should be. What should the formula be if copper is 2 plus and nitrate is -1? What should the formula be? That is basically chapter 3. What should the formula be for copper and nitrate?
You have the Cu current, this is the nitride.
Yes?
The current is the Q oxide.
Exactly. So it can't be just copper and nitrate. If copper is 2 plus, now that goes back to chapter 3. Does that make sense to you all? So copper will combine with nitrate in what combination? 2 plus, if copper is 2 plus and the nitrate is only -1, it means that I have 2 of these, right? And that is the correct formula, okay? That is the correct formula.
So if we reach this question, what would we do about the something?
Exactly. I will tell you that. That I will tell you, yes. And you're absolutely right. There's no way you would know that by looking at it, right? I will tell you that. But once I tell you that, if you don't do it correctly, you won't get any credit. Now, you must appreciate, some of you in lab again did the balancing, but you will appreciate that this equation is not balanced. That's coming up. We're going to balance today. What do I mean by balanced? The number of atoms need to be the same on both sides. So if I have 1 copper atom on the right, there must be only 1 on the left. If I have 1 nitrogen, there must be 1. Or if I have 2, I need to have 2. That's called balancing. That is not something you do before you write it correctly. You need to write it correctly first, then balance. Did you all understand that, folks?
I have a question. Is it better to write the copper first and then?
No, no, that doesn't matter. The order in which you write does not matter. Okay? Okay, so that is now for, let's write this reaction, everybody. Replacement of copper by zinc in copper sulfate. And again, I don't like how they've written copper sulfate. See, even textbooks make mistakes. What do you think? Did they write copper sulfate correctly? Yes, there should have been a Roman numeral in the name copper sulfate, right? So you go ahead and write down the question for me. Replacement of copper by zinc in copper, Roman numeral 2 sulfate. Roman numeral 2 sulfate. And zinc, Zn, I want all of us to do this together. Zinc, is it an A group or a B group? It's a B group. That means I need to give you its charge. Okay? So the charge of zinc, assume like I told you, I will give you the charge, put down the charge of zinc as 2 plus. Now, do the problem.
How much is it?
2 plus. So what should the formula of copper sulfate be? What should it be, folks? If copper is 2, if the name is copper Roman numeral 2 sulfate, what should the formula be? CuSO4. How many of us got that? Yes, do you follow? Because sulfate, now if you're wondering what is sulfate, I don't even remember that. You have your book with you, you need your list. What is that list? The polyatomic list? You need to have that. Okay? So the formula is CuSO4, and I hope you can appreciate that that's not going to make any sense if we don't know chapter 3. That's why I don't review. Because it simply means you need to know all the chapters before 4 to do 4. Okay? Otherwise, you're going to be perpetually lost. Now, can you go ahead and display this, please? It's a single replacement. What's the product going to look like? Have you done it, Corey? Copper is going to be replaced, right? So what's the other product? It's just that. Is the formula zinc SO4 or zinc twice SO4 or zinc SO4 twice? Well, it's just going to be ZnSO4 because Zn, I said, is in what state? +2, right? Yes, they're all +2. Does that make sense, people? So your job is to do this for me on the test. How will the question look? It'll look just like what you saw. Replace copper by zinc in copper sulfate. Show the reaction for the replacement of copper by zinc in copper sulfate. Yes? How about you try the second one now? Replacement of aluminum by sodium in aluminum nitrate. Replacement of aluminum by sodium. Again, got to know your charges to do this. Okay, tell me how to do this, folks. What am I starting with on the reaction? Okay. Okay, Na plus, what is aluminum nitrate? There should be a 3 outside? Yes. Excellent. Okay, everybody understands why there's a 3 outside? Very good. Now replace it. So now I don't need to give you the charge because these guys are not the decoys. So you should know the charges, right? Okay, so we replaced it, right? So give me the formula. What are the products going to be? Rebecca, what are the products going to be? What's getting replaced? So would it be by itself? And what else? Plus. Okay, anybody else? What about you, Josh? What's the charge on the sodium? I didn't give it to you, but I want you to know it. Plus 1. What's the charge on the nitrate? So why would it be any? It's just what? NaNO3. Does that make sense? Now again, it's not balanced. That's a different story, but please don't make an attempt to make, what I see on the test is not this. What I see on the test is NaNO3 thrice. People are copying from the right to the left. That is not what we're doing here. We're putting the right formula based on charge, and then we're going to balance it later. Does that make sense to everybody, please? This is correct. Aluminum by itself, because after all it got replaced, sodium and nitrate will only combine. See, aluminum needs 3 nitrates. Why? Because its charge is +3. But sodium doesn't need 3 nitrates. Its charge is +1. So they all combine differently, right? Make sense? Okay. Now, that's a single, but you may also have a double. The doubles are 2 compounds come together. Hey, it's like two compounds come together, and they swap partners. Do you follow what I'm saying? Okay, so look at what's shown here. A goes with D, and C goes with B. And I got asked this question in the other class. Well, what if A went with C and B went with D? Why can that not happen? Okay, keep in mind, these are ionic compounds. So what is A? In AB, what is A? In an ionic compound, what's written first? Metal. So A is a metal. Will it go with C, which is also a metal? No, 2 metals cannot come together. And 2 non-metals won't come together. There's no incentive. They want to go with opposites, right? So A can only go with D. Do you get it? And C can only go with B. So there's no other combinations possible. Get it, folks? And another thing to remember is the same story. You got to put the charge, swap them, and write them based on their charges. Get it? So I want you all to do this problem for me. It's on the slide, but I'm only going to read it to you. So I'm going to say lead nitrate and sodium chloride. Swap. I don't want you to see the slide. Can you write the formula for lead? Okay, let me write the name down. Can you write the formula for lead, Roman numeral 2 nitrate, and sodium chloride? So see how much of 3 you need to know to do this? Lead, Roman numeral 2 nitrate, and sodium chloride. Now I want you to swap partners for those 2 guys. But to do this problem, we need to come up with formulas for these 2 boys, right? Now if you're wondering, why did she put the Roman for lead? Lead is not even with lead. Yeah, PB. Is PB in the B group? Why did I put the Roman? Because remember, chemistry is a subject full of exceptions. More than rules. Lead is not a B, but lead has 2 charges. By the way, what should lead's charge be based on where it is in the periodic table? 4 what? Minus or 4 plus? Why plus? Can it be minus 4? Wait, but what is lead? That's when you will know the answer. What is lead? Is it a metal or is it a non-metal? It's a metal. If it's a metal, it will never be negative. So lead will always be plus 4. So you're right, it can be plus 4. But guess what? It can also be plus 2. As soon as you have a metal that has 2 possibilities, you need to give a Roman for them. Right? So lead is an exception. It can do 2 things. It can be a plus 4 or a plus 2. So I have to tell you which one. And that's why in this example, don't choose the plus 4, choose the plus 2. Okay. Because there are 3 possibilities. Anytime you have 2 possibilities, you need to put the row. all have two possibilities, yes. But the A's don't have two, except lead. Right? Lead is the unique guy who gets to have Roman because he has two possibilities. Okay, did you come up with the formula already? Hopefully all of you got sodium chloride, right? What is it? Okay, so what's lead nitrate? Who can give lead nitrate for me? Corey, did you write it? What is it? Good. Did y'all hear her? Okay, do you agree with Corey? Okay. She said PB. No, it's lead nitrate, correct? By the way, the reason I'm doing all this weird looking things, folks, because I could just as well write very neatly on the board, but I'm doing this because it gets recorded here. It doesn't get recorded if I do it on the board. That's why. I hope you can read it though, can you? I'm trying my best to be neat. I mean, you would think if they did all this canvas, they would let a stylus work. But it doesn't. You saw me write worse with the stylus. The guy who was here, Jacob, the really sweet professor, he told me the stylus won't work, but I went and bought it to help you see better. But I think it's making it worse. It has a lag time. Yes, on a Dell venue. Yes, but guess what? Get this. They have Dell venues for teachers who want to walk around because I don't want to be stuck here. The reason I'm standing here is because of the microphone. Because I want to go outside, I want to walk. But if I stand there, you won't hear what I'm saying. So you use a Dell. The Dell, the problem with that, get this, the microphone is very weak. So Jacob told me that he has to scream, and even then they can't hear what he's saying. I'm like, oh my God, this is challenging, but I'm not going to let that get in the way. And you know how tech savvy I am. I'm not going to know how to do that. I have to work with my limited abilities. Not make it. You know? Yeah, I'm going to have to talk to him because I have the tablet. I just don't want it to be a useless reference. It will work with that. I'll try to get it out. I'll get it. I promise. Okay, so folks, help me swap. So what I would do if I were you is put the charges above. So I'm going to say lead is +2. Yes, and so the sodium is +1, and chloride is -1, and the nitrate is -1 also. Got it? So now swap. Lead goes with Cl. Get it? So how would a +2 and a -1 combine? PB. Okay, so I'm going to write it here. PbCl2. Agreed? Plus. Sodium and the nitrate are -+, +1, -1. So those guys are going to be NaNO3. See? It was easy if you know the charge and you know chemistry, then you will do it. What I see on the test is then not this. I see PbCl and NaNO3 plus. What has the student done? Just copy. Okay, so chemistry is not copying, so fix it, do the right, then you learn to balance. Got it? Good. So this is what you will have to do all of this for me, and the question will read as such. It will say double display. So let's do a problem from the book. Okay, so let you know how the question will look on the test. Oh, they don't have any for double display. Never mind, because we're going to do this. Okay, we're going to do it as a part of another thing. So let's just keep moving on. We will do it again though, because there's a precipitation, predict precipitation, and it comes in there. Okay. Oh, so it even, okay, so where are the precipitations? Let's see. Okay. Now, when it talks about predicting a precipitate, I want all of us to look at page 145 of your book, folks. is 145. Okay, everybody? Predicting whether a precipitate will occur. For that question, you're going to have to use a little chart like this. That's the solubility chart. Can everybody please look at this chart? It's called the solubility chart. Okay, now, I want us all to look at practice problem 4.14. It says predict whether these following reactions, when mixed in an aqueous, will undergo a precipitation reaction and write a balanced equation. Everybody looking at that problem, please? Practice problem 4.14 on page 145. Everybody got that? Good. Now I want you to look at D as in dog, sodium hydroxide and iron chloride. Everybody got that? Now what you have to do here is the same thing we did. You need to swap partners, write down the product, and then we're all going to turn and look at this little chart, and we're going to decide whether we have a precipitate. Get it? So what I want you to do for me is this. The chart is on the very next page. It's on 146. The problem is on 145. So let's all do G as in dot. Sodium hydroxide and iron 3 chloride. Sodium hydroxide and iron 3 chloride. What I need you to do is swap. Oh, sorry, iron 2 chloride. Sorry. Sodium hydroxide and iron 2. So what's the formula for sodium hydroxide? Justin, did you get it? NaOH. Yes, NaOH. Yes, everybody? Good. What's the formula for iron 2 chloride? Fe. It's iron 2 chloride, right? Not iron 3. Iron 2 chloride. Isn't that what the problem says? In your book, what does it say? Iron 2? Then in that case, the formula is going to be FeCl2. Yes, everyone? Now, I would swap the partners, but before I do that, I put the charge above each of these guys. Sodium is +1. OH is what? -1. Fe is what? Very good. +2, and chloride is -1 as well. Draw an arrow between the new partners. Sodium goes with Cl. Agreed? Good. And Fe goes with OH.
When the Cl switches, does it take the 2 with it?
No, it does not. And that's the point, right? It depends on the charges. So if Na is +1 and Cl is -1, yes, they cancel out. So why would it be NaCl2, correct? What would the formula be? Exactly, NaCl. Is everybody agreeing with me so far? Plus, what would the other formula be? That's it. FeOH within parentheses twice. Did everybody get that? Because if you look at the charge on the Fe is +2 and the OH is only -1. So you need 2 of the -1s to balance 1 of the +2, right? Now what we're doing, folks, is look, draw these little parentheses. And we need to fill those up with either the letters AQ or the letter S. What does AQ stand for? Aqueous or it's dissolved. And C is a solid, therefore a precipitate. Is everybody with me? Now we flip the page to the chart. The chart is very interesting to read, and I need you to read this safely. Okay? Understand how to read the chart. Soluble compounds, which are those, and obviously the chart's not going to say iron hydroxide. It's not going to say sodium chloride. It's going to give a general class. Let's do the first one, sodium chloride. Ready? The compounds containing alkali metals, such as lithium, sodium, potassium, rubidium, magnesium, and the ammonium ion are all generally soluble because they're undersoluble, correct? The sodium chloride contains sodium. Yes. And then if you look under solubility, not the second rule, not the nitrate, but the third, halide, chloride, bromide, iodide, those are soluble too. So it seems to me that NaCl should be, therefore, am I going to put AQ or am I going to put S? S is not soluble. S is solid. So you need to put AQ.
So how do you know if it's AQ or L? Or liquid?
Liquid is when it is water or something like that. It'll be a big. Right now we're not doing liquid. We don't say liquid. Liquid means it originally exists as a liquid. These guys are all mixtures, so you have to say soluble or insoluble. That means not S, AQ or S. AQ is soluble, S is not soluble. S is solid or insoluble. Very tricky, I know. Okay. Next, iron hydroxide. Let's go through the rules again. Soluble compounds. Compounds containing alkali metals, lithium, sodium, potassium, is iron water. Move to the next. Nitrates and bicarbonate and chlorate. Do we have any one of those in iron hydroxide? Do we have? No, does the rule nitrates, bicarbonate, and chlorate apply to iron oxide, hydroxide? Oh, no, it does not apply. Move to the third. Halides, like fluoride, bromide, and iodide, are soluble. Do we have one of those in iron hydroxide? Yes. Sulfates are soluble. Do we have a sulfate? No. Those are insoluble. Carbonate, phosphate, chromium, sulfides. Do we have one of those? Yes. Hydroxides are insoluble, generally, but definitely look at the exceptions next to it. It says hydroxides are soluble, but if you look against the exception, it says compounds containing alkali metals and the barium ion are soluble. An exception means an exception to the insolubility rule, right? So to make it soluble. However, iron is not an alkali metal, and neither is a barium. Agreed? So by those rules, we would conclude that iron hydroxide is a solid or a precipitate. Yes? So we need to say one. Is everybody agreeing with how to read the rules? The rules are very general. You've got to understand what you're looking for. It won't give you the name of your compound, but it'll give you a general class. Yes? Good. So let's do another one. Ready? Can you predict the precipitate for this reaction? B as in boy, potassium acetate and silver nitrate. B. Potassium acetate and silver nitrate. Potassium acetate and silver nitrate. What is potassium acetate? What's the formula? You can write it either way. I would just do KCH3COO. Yes? Now, is that correct? Is that formula correct? No parentheses, nothing?
So they cancel each other off, so you take two things. And filter is one choice.
Or if you have different numbers, you can put the parentheses. I really don't care. What is silvernite? What is the next compound? What is the next compound? Potassium acetate and silver what?
Nitrate.
Silver nitrate. What's the formula for silver nitrate? AgNO3. And the charge on the Ag is +1. The charge on the nitrate is -1. Shall we swap? Potassium would go with what? NO3. And the silver would therefore go with the other guy, right? Acid. So far, so clear? Now swap and put the formulas correctly so as to put the charge, right? Cancel the charge. So how would K and NO3 come together? KNO3, yes. Make sure you leave a room for the state. And what would the other thing be? Very good. AgCH3COO. Also make sure you have some room for the state. I'm sorry? Yes, yes. You can have a solid and a liquid. Yes, absolutely. All right, now use your little solubility chart and tell me, do we have a precipitate? By that I mean, does any one of them have an S? Yes. Solid. No. Look at the rule. You have to look at your rules before you decide. That's highly unlikely. No. Yeah. I don't think that's going to happen, that you have two insoluble. For the acetate? Okay. Well, here's the thing though. This chart does not even have acetate. Okay, so I can just tell you that you can add it to your list. Acetates are very small. Okay, what about KNO3? Were you able to decide on that? Very good. Yes, KNO3 would definitely be KCS. Silver acetate, I understand it's not your fault because there is no such thing as an acetate on the list. But silver acetate is fine. So it is aqueous. Okay, wait, so how do you know that Ag license you?
Do you look whichever one on the chart, whichever one you find?
No, AgCH3COO is not on your chart. Generally, they're listed by the anion. The groups are listed by the anion, by sulfate, hydroxide, carbonate, chloride. You see what I mean? So, anion is the acetate listing. And the anion I don't see on the chart.
So what do you say?
So it is soluble, but I would have to give you a different list that has acetate on it. You are not held responsible for not knowing something that's not on the list. Is what it is. Yes?
Are we given the list?
Yes, you're given the chart.
So the Ag.
You're given the chart. AQ. Huh? Yes, you can get 2 aqueous, but you don't get 2 S. You cannot get 2 S's, you can get 2 AQs, yes? Certainly you can have 2 AQs, they're just so soluble. But you're unlikely to have 2 precipitates, you're likely to have 1 precipitate. So that puts a precipitate is the same thing as solid, which is the same thing as gas. Very tricky, I know. Soluble is AQ, insoluble is S, and that's that sort of solid. Yes, they can be 2 aqueous. Yes. Everybody got this, please? So now we move on to